Let's Take This Outside with Marianne Iveson, the podcast where she speaks to athletes, outdoor professionals, and scientists about why they connect with nature.
Dr. Cassandra Marion is the science advisor for the Canada Aviation and Space Museum in Ottawa, and her passions include the outdoors, rocks, and space. She completed her PhD in Geology and Planetary Science and Exploration at the Earth and Planetary Institute at Western University. Her studies focused on meteorite impact craters and lunar and Martian analogue environments in the Canadian Arctic and subarctic. After 13 northern expeditions, she has developed considerable expertise leading and managing field expeditions and had the privilege of assisting in the expedition and geology training of 3 astronauts. Please welcome Dr. Cassandra Marion. Cassandra Marion, welcome to Let's Take This Outside. I'm so stoked to talk to you.
I'm stoked to talk to you too.
Usually I have people who study Earth, but I think you're my first space person. So this is like Let's Take This Outside to literally another planet.
Woot woot.
I love talking to guests who are local, who do very cool things. Are you from Ottawa?
I am not. I'm from Midland, Ontario, so about 5 hours away. But I did my undergrad in Ottawa and then moved back here just a couple years ago.
Where did your love of the outdoors, of rocks, of space, where did that all start? Because I think a lot of kids want to dream of what you do.
It's kind of a 2-camp thing. The love of space definitely came about, by watching Star Trek and Star Wars and just being a complete nerd as a child. I was definitely an escapist, watcher/reader. Coming from a really small town, small community, it never occurred to me that could be a career choice. And then my dad was a very outdoorsy person, and I started paddling when I was about 10. And so spent most of my summers in a tent and most of my days in a canoe. And that's where the love of sort of nature and rocks and just being outside all the time came from. It was like my happy place. Anytime I needed to escape, that was where I went. And then going through school, my best subjects were science and math. So I actually, when I started my undergrad, I went into physics. I did a year of physics. And then I thought, this is not fun anymore. It's interesting, but it's not fun. And I took a geology elective. And I was like, volcanic eruptions, earthquakes, the earth is moving. It was just the coolest thing ever. And I was like, this is for me. And an academic advisor was like, where do you like to spend most of your time? Outside? She's like, yes, change. And then I was hooked. I just loved everything geology from that point on. And I fully intended on being a hardcore geologist. And then when it came time to what do I do after my undergrad, I wanted to travel a bit. So we did that, did a trip to Hawaii and did a little geology expedition stuff. And then I decided I'll do a master's and I'll just expand because I just like everything. And I was open to opportunities. And I had the opportunity to start a master's in Newfoundland. And the project that was offered was to work in an impact crater, a meteorite impact crater in northern Labrador. So in a really isolated region. But the coolest part is that not only could I get to work on rocks, but that this was a lunar analogue site. So an analogue site is an environment or rocks that are similar to an environment on another planet. And in this case, the rocks where this impact crater hit, basically where this asteroid smashed into the Earth, were very similar to the rocks on the moon. And so you could draw a bunch of, links and interpretations that would work as well in Labrador as they would on the surface of the moon for this impact crater. And so that was the coolest thing. And that was the first time I could sort of mesh. I learned that I could mesh both geology and space together. And I was hooked from then on in. Hook, line, and sinker.
Okay, so you say Newfoundland, and I've not been lucky enough to go to Northern Labrador, but it seems outer worldly. So I went to Newfoundland in June, and I was lucky enough to go hike in Grossmore National Park, where they have the tablelands, which is actually like the Earth's mantle, which you can only find a few places in the world. So I have to ask, is that the kind of rocks you're talking about, or is it something different?
Very different. Yeah, very different.
Oh, okay.
but tablelands is very cool.
Because tablelands, to describe it, it's kind of like this orangey kind of color, but it kind of looks like Mars, a little bit. Am I wrong? I don't know.
Color-wise, yeah, it looks kind of like Mars. And I will say that mantle material is very iron rich. The composition of those rocks are very similar to some rocks that we definitely find on Mars and on other planets. But on those other planets, you're very rarely be able to actually see the mantle exposed because the Earth is the only planet with plate tectonics. And so it's the only time when you really get that mantle to the surface, with the exception of a giant impact.
I don't want to get into the weeds too soon, but when it's funny because I almost forget all my basic geology from like high school. And so the Earth, can you just make it very simple, like you're talking to someone in grade 3 who's probably smarter than me in this stuff? The Earth, we have the core, and then we have the mantle, and then the crust.
Yep. And there's actually there's a couple of different layers. There's like an inner core and outer core, and lower mantle, upper mantle, and then the crust has got a couple of layers too. Basics is like iron nickel core. Then the mantle is like, where things are convecting and swishing around and it's warm. And then the crust is what we're standing on.
Got it. Okay. I think so many kids are like, I want to be an astronaut. I want to study space. But you really pursued your passion for space. Do you see a lot of kids be like, oh my God, what you do is so cool?
Well, definitely what astronauts do is so cool. I think the things that they think are cool is when I go on a big expedition and then I'm showing I have to take a helicopter to get here, or, I get to climb this mountain and show them all the cool rocks that I bring back for fun. And yeah, definitely it's the easiest thing to sell, being an astronaut. But yeah, so many kids have asked me, what do I have to do to get to be an astronaut? Space is an easy sell because it's so much the unknown. There's so much to discover, so much and it's so inspiring. It's easy to get kids engaged on the topic.
Tell us exactly what you do, because my brain is too small to understand what lunar and Martian analogue environments means in your bio. So can you describe maybe what you did before, but now you're more like outreach and trying to help people understand space a little bit more now. But what did you do before? What do you do now in layman's terms?
So by training and all my research, basically what's called a planetary geologist, which basically means that I study rocks on Earth, but also on any other solid body in the solar system. So whether it's Moon, Mars.
Just this solar system, though.
Well, these are the ones we can get to.
Right. Okay.
Mostly. And even then, it's pretty challenging. And so most of the ways in which I, in particular, study those, rocks elsewhere is by studying rocks on Earth in the Canadian Arctic, which are in an environment in many ways very similar to, let's say, the surface of the Moon or the surface of Mars. And that's why we call them lunar analog or Martian analog environments. There are just similarities. Either it could be that the rocks are very similar. So like in Northern Labrador, when I was talking about the same rock type as parts of the Moon. Or it could be just that we're in a very isolated area. We're in an Arctic desert. So surface of Mars, for example, it's very cold, windy, no vegetation, very isolated. Help is quite far away. And so when you're doing remote field work, you're basically, it's almost like you're on an analog space mission, because you're going really far away. You have to, pack everything, take it all with you, food, sometimes water, all of your instrumentation, everything. You go, you do your science, and then you pack it all back up and you leave only footprints and you come back, right? It's a dangerous, pretty high risk environment, but you're still expected to complete these really sort of high quality scientific research by the time you get back. And that's very similar to a space mission.
What kind of things would you be studying or sent to do in the Canadian Arctic and subarctic?
A couple of different things I study, but the main thing is these meteorite impact craters. So if you look on any solid surface in our whole solar system, the most common feature that you see on the surface are those round looking holes in the ground. They're just the craters. You can see them with the naked eye when you're looking up at the moon at night, right? And so Earth has those as well, but it's very difficult to get to the surface of the moon or to the surface of Mars to study those craters. And so we go to the Arctic, where it's very accessible. Some of them are very well preserved. There's one particular crater called the Houghton impact structure. It's on Devon Island in the high Arctic. And it's one of the younger craters that we have in Canada. And it's over 20 kilometers in diameter, but you can cross it in a day and, look at the different rocks and different processes going on and sample. The tricky part is getting there. But the more we understand what's going on with that impact structure, then I can make inferences, right? I can draw conclusions about this one that I maybe explain what we see on the surface of the moon and an impact crater there, for example.
So when a meteor hits Earth or has hit Earth in the past many years ago, does the meteor just like incinerate? Does it explode? Does it leave? I'm assuming it leaves matter behind, and that's what you're studying?
It's a bit of a mix. So in this particular instance, when you have a very large impact, let's say something on the order of like 2 to 5 kilometers in diameter, a projectile impacts, most of that asteroid is just completely destroyed. It's vaporized, but it's not that the material disappears. It just intermixes with all of the rocks. And that actual impact, there's a huge amount of kinetic energy that is transferred into what's like very high temperatures, very high pressures, and a huge shock wave is created. And that shock wave is really what digs the hole and is also what basically destroys that projectile. And so you might have an impactor of 2 to 5 kilometers, but then you have a hole that's some 25 kilometers in diameter at the end. And then it's just completely chaotically fractured and broken up all that rock. It has melted kilometers worth of rock, basically made a lava on the surface, and it has vaporized a bunch of rock. We've tried to describe that process in simple ways, like there's a layer that looks like this and a layer looks like that, but when you're on site, it's pretty chaotic.
I have a lot of questions out of this, and I don't want to get too dark, but this is where my mind goes as a human being. How big does a meteor have to be to wipe out the existence on the planet?
Ooh.
If one was to happen again.
It'll depend on, the speed it's going, its composition, things like that. Mostly its speed and its mass. How big does it have to be? It has to be pretty big. I mean, it doesn't have to be very big to take out a city. If you've got something that is on the order of 5 kilometers, no problem. You can take out a city and make a big mess, probably take out a province, really. But I can tell you that you don't have to lose any sleep over this. Because
yes, that was my next question was like, what are the chances of it hitting? I know water's mostly Earth. I get that, whatever. But what are the chances that a meteor that would be damaging would hit Earth that's near a populated area that would cause a problem?
I won't have exact percentages, but what I can tell you is we have scientists that are continuously monitoring the skies, and we are tracking every near Earth object that's an asteroid that comes remotely close to Earth's orbit. We're tracking, there are thousands of them, but we are tracking all of them that are about a kilometer in size and bigger. And so those are basically all of the ones that would cause major, major damage. There are plenty of smaller things that, can take out a car or break your windows or things like that. And we get impacted by meteors every single day, micrometeorites every single day, things on the size of like a basketball size, quite frequently. The Earth's mass is growing very, very slowly. Because we're impacted constantly by just little things. And about once a month or once every 40 days, we get what's called a fireball. So something slightly bigger that does hit the ground, and we can go and track it and pick up those meteorites. But these are things that will dent your garage door, but are not going to take, like, your house won't blow up.
Have you ever heard of someone being like, I had this weird thing happen, there's a huge dent in my car, or there is something like, or I was walking and this thing, like, have you heard of stories like that? That it's like, I was walking through the forest and this huge like rock came through. I've actually never heard of anything like that happening.
When I was back at Western University, there was a meteor physics group. And when things hit, they would get the reports. And so I actually was part of the search for what's called the Grimsby meteorite. Grimsby is a small town in Southern Ontario near Niagara Falls. And that's exactly what happened is we have cameras all over Ontario that watch for meteors. And if there's something big, then they try and go meteorite hunting, right? Like try and find the rocks. So we saw it come down. We knew that we'd find pieces in about a 20 square kilometer area. And so we just went on the hunt. And then our group put notices in people's mailboxes and on the news saying, hey, if you saw something, you picked something up in your yard, let us know. And that's exactly what happened. There is a piece that came down, smashed into someone's car, and it bounced off the car, like smashed the windshield, bounced off the windshield, and dented their garage door. And then they kept it. They didn't know what it was at first until they saw the announcement. They called, and then our crew went and got it.
Is that worth anything?
From the scientist perspective, the passionate meteorite collectors and things like that that are studying those, it's worth all the scientific discovery. But meteorites themselves can be, if they're a rare type of meteorite, can be several thousands of dollars. If you get a rare one, or like a lunar or a Martian meteorite, yeah, they are very, very expensive. And there are people that make careers out of hunting meteorites and selling them. No joke.
That's some like deep internet stuff I've never heard of before.
Let's Take This Outside now has a newsletter. Keep up to date with outdoor news, events, and great discount codes and deals from our partners. Sign up today at letstakethisoutside.ca.
Why is studying space so important to life here on Earth?
Wow. Okay. There's a bunch of different ways you could go at this. One is just scientific discovery. We are a very curious species. We are explorers at heart. Even those who maybe not be into, nature and things like that, we just like to understand the world that we live in a general sense. And so space is sort of that next frontier, the bottom of the ocean and space exploration. And so that's where we're at. But in a more practical sense, all of the efforts that have gone into space exploration, all of these huge advancements in innovation and science and understanding have led to some amazing technologies that change our modern culture on the surface of the Earth. There is not a single day, and you in particular, we're using it right now, that you do not use space technology. You're either on your GPS, if you're on the telephone, if you're on the internet, if you're even just taking a selfie, the sensor in the made very small camera in your cell phone, all of that was developed for space by, funding for space things, and then just reused or revamped to be able to be used by everyday person. And many of those things had the intention. A lot of the funding in Canada specifically is when we're developing technologies, especially medical technologies. So, medical care in space or food technologies in space, those can have huge return when we reuse them on the surface of the Earth. So think about growing food in a remote location. Okay, now we can use both the remote medicine and remote food technologies in our remote and northern communities in Canada, which we have a lot of and that are in need of those technologies, right? So much of that tech can be reused.
Is it true, I've heard this, I don't know how true it is, that we know more about space than we know about the depths of the ocean?
In many ways, yes.
Really? Isn't that scary? It's a little scary, right?
And I'm not an ocean scientist, so I can't fully answer the question. But yeah, absolutely. It's really hard to get to the bottom of the ocean because the pressure is so high that we've not done it very often.
What's it like to work with astronauts? Because they are another breed of human being, right? They're the people who are not only doctorates, but they also are multi-Ironmans, and they're they're good at everything in their life. Is this true that they're just good at everything in their life?
I think that what is consistent for all astronauts that I've ever had the great honor to get to know and work with is that they are just wonderful people and that they are amazing in working in a team and they are driven. They are absolutely intelligent, but that doesn't mean that they're the best at everything every time. It just means that they are really well-rounded. They're just wonderful people, very intelligent, and great with working with others and working with a team. And that's really what you want. You want somebody that you can put your trust in. When you're in a crew, you have to put your life in each other's hands. You're reliant on your teammate, right? To get you through and to be able to do their job. And so every single one of them, I was like, they made the right choice there.
Well, we just saw that, and you would know more than I would, but we just saw that with those two people that got stuck in space, right? You'd want to get stuck in space with someone that is easy to get along with, right? They're safely back home now, right? They were able to get them back.
No, they're still up there. They're still up there, but they're fine.
This is September 13th, when this isn't coming out till later, but hopefully by the time this is released, they are back home.
They will be coming back in February, I believe. The capsule, the Starliner capsule, has returned safely, but it came down empty. They didn't want to take the risk in case. So they decided to have them, the next crew that goes up, the next Dragon that goes up, they just took 2 crew members off of it, and then they'll just join the next crew down in the next capsule, basically. But that'll be in February. So it's an interesting story. Lessons to be learned there. That's what I'll say about that.
Is there anything you want to talk about there? Or are we just going to
Yeah, probably shouldn't. I will say astronauts, it was a test. It was meant to be a test. And those 2 astronauts that went up, they were prepared for the unexpected.
Every mission is very high risk, I'm assuming.
to be the first crew to be on that space capsule. There's always the whole point of it was to test it to see if it would work. And then they identified problems. And if they weren't able to fix them that gave them enough confidence to send them back home in it, they found an alternate way to get them home safely. And that's what's important.
What is the coolest thing that you have discovered in your studies?
I don't think there's one big thing. It's always like the everyday things where I'm just constantly surprised, whether it was even in the field or back in the lab. You know, you crack a rock in half and then it turns out to be something entirely different than what you expected. And it's just those small joys, whether you're in the field or in the lab and you analyze something and it just comes back something very different than what you expected. That's my favorite part. No fascinating discoveries that on a big scale.
I think what you do is so cool, though, that like for you, it's maybe not a big deal, but like for all of us, it's like, oh no, what you do is you go to meteorite sites and you like look around and you just, you cross. Anyway, that's so cool.
It's exploring, right? It's just like if you're going to try out a new hiking trail with your family and you're like exploring through the bush and you find some weird mushroom on the side of the tree. It's just that same feeling where I'm like, ooh, this is so cool. Ooh. There's a lot of
You're like, I haven't found anything cool, but like I saw this mushroom last week in the forest and it was amazing.
And I just get equally excited about rocks. So it's pretty much that.
I hear that, you love talking to kids because sometimes they school you. Like a 10-year-old has schooled you with questions. Tell me more about that.
Yeah. So now at the museum, a lot of my, let's call it the day job, is doing a lot of outreach, a lot of science communication with all ages. But my favorite is when I've got a group of really engaged students and I get a question that I can't answer. And that means that I have to go and research and find out. And I'll say, I don't know, but like, let's find out together. Or I'll be like, ask me in an hour, or I'll email you the answer later. But sometimes you get really keen students. And as much as I have a specialty in planetary surfaces, I don't know everything. A lot of experts, their field of where they're experts is very narrow, right? And so going outside of that, there's so much that I still have to learn. And so I'll get a student that's really into astronomy. And I'm not an astronomer. I know a lot about space, but I'm not an astronomer. They asked me a question. I'm trying to remember the last one. Actually, it was about Jupiter's largest moon, Ganymede, which is the largest moon in the solar system. And he offhanded asked if it was like bigger than some other moon. And I couldn't remember the relative sizes. And then when he realized that I wasn't all knowing, because some kids, they just assume that experts know everything, right? Then he started like throwing questions at me like, do you know that the M1 galaxy and this was, this many light years across? And I had no idea. He just kept going. And I was like, I didn't know that. And I invited him to come up with me like, do you want to come and present with me up here? You talk about galaxies and I'll talk about the rocks.
But you want kids to be that excited about space, right?
Absolutely. That is the most wonderful thing. I think it's really important that people know that scientists aren't all knowing. We only know what the evidence shows, and we're exploring to answer those questions. The start of a research project, for example, always starts with a question you can't answer. So I think it's really good for first kids understand that, we have questions that we still need to answer, and we don't have that. You don't have all the answers. No one does. And I just love it when they just jump on you, because I'm like, okay, well then you help me find the answer. How about you find it?
Yeah, empowering them. Yeah,
exactly. Yeah.
Okay, I'm going to ask a question that I'm sure kids ask you all the time, but do aliens exist? Have you been to Area 51? I have so many questions.
I have not been to Area 51. I can't speak to that part of things. What I can say is it is statistically unlikely that the only life in the universe is on Earth. So that's to start. So do I believe that there's life beyond Earth? Probably. So the answer for me is yes, because it's more likely that there is. The tricky thing is there going to be life that is sort of at our level of intelligence that we would ever meet? Probably not, because if there is, if there's no one close, that's for sure, because we would have detected them by now. But there's definitely life out there. I just don't know if we'll ever reach it. We'll ever have, one of those Star Trek encounters, just because, they're hundreds of light years away. So that's the big challenge. But I think we have a pretty good chance of finding like bacterial life or some small organisms within our solar system. maybe one day on a moon of Jupiter or Saturn or in the subsurface on Mars, we might find some evidence that life once existed there.
Can we leave it there, please?
Oh,
Can
yeah.
we not bring it back? Let's not bring it back. That's how alien movies start. We can't bring it back.
Yeah. There actually are committees on, the ethical exploration.
Really?
Oh, yeah. Yeah. Anytime we send any spacecraft or anything to go looking, well, just in space in general, we do our utmost to not contaminate the other space that we are exploring, and then to not contaminate Earth when they come back. That's why there are so many protocols put in place to reduce contamination both ways.
This is so cool and so enlightening. Do you ever do talks or anything? Because I would love to come to one sometime.
At the museum on occasion. Yeah.
Okay, I'll keep an eye out for it.
I'll send you an invite the next time there's one.
Please do. I will post everything, like some of your cool videos as well. I post everything in the show notes. But I have to ask, what do you do now for fun outdoors? Do you still paddle? Do you ever look up into space at night and you're like, we are so small and insignificant? How do you look at things now outside of work?
I absolutely still do that. I'm just a big nerd and proud to be. So I enjoy the same things through the eyes of my kids. So I still go canoe camping. My daughter, for the first time this summer, we had her paddling down some rapids and she loved it. So we're still canoe camping and just whole family. And then I can say just recently, we've had a bunch of solar storms. So there's been some aurora that you could see fairly far south, right? Did you see that?
I haven't seen it with my own eyes because I'm usually asleep in the middle of the night. But Southern Ontario has been so lucky with it, right?
Yeah. And the sun is almost at its maximum in its activity cycle. It's on an 11-year cycle. And so we're getting a lot of different solar storms in and now. And so you can see the aurora much further south. And so I brought my kids out. I kept them up until midnight, on the side of the Ottawa River, a little ways away from the city, just to see just a hints of green on the horizon.
Cool.
So yeah, we're still doing it.
That's great to hear. Thank you so much for opening up your brain for us today, for Let's Take This Outside and all my stupid questions. Thank you for answering.
No stupid questions.
Cassandra Marion, really appreciate it.
My pleasure.
Thanks for listening. For more Let's Take This Outside, go to letstakethisoutside.ca.
Produced and distributed by the Sound Off Media Company.